Good morning. This is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. In this lecture, today we are going to discuss about testing of hypothesis for difference of means. In the last lecture, we have discussed about testing of hypothesis for single mean. So here, single mean is one sample data is given. Difference of means is two samples data is given. How to test the hypothesis? The testing of hypothesis procedure is the same for either a single mean or difference of means. So the first step is, again we claim about the population mean, and alternative hypothesis we can define in three ways, either two-tailed or one-tailed, greater than or less than or not equal, and level of significance, that means the error in our claim. Fourth step is test statistic. So what formula we have to apply for two samples data is given. In one sample data, we applied z is equal to x bar minus mu by sigma by root n. So in two samples data is given. So to test the mean of the populations, then we apply the test statistic is z is equal to x1 bar minus x2 bar minus delta by under root sigma 1 square by n1 plus sigma 2 square by n2. So here two samples data means two populations P1, P2. Two samples N1, N2. So this is size of the first sample, N2 is size of the second sample. This sample is taken from first population and this sample is taken from the second population. So here we are testing the hypothesis as these two population means are equal. So mu1 is mean of the first population and mu2 is mean of the second population. Now our claim is these two means are equal. There is no significant difference between mean of the two populations, or we can define or we can claim that these two samples came from the same population. Only one population, two samples are selected, N1, N2. Both are same. From one population, we select two samples, or from two populations, we have selected two samples. So, if two populations are there, then we claim that these two population means are equal. That is mu1 equal to mu2. Suppose from one population we have taken two samples, then we claim that these two samples are drawn from the same population. So this is a null hypothesis. So here delta is the difference between the mean of the two populations. That is, difference is mu1 minus mu2. Our claim is there is no significant difference between the mean of the populations. So that's why this value is 0. So mu1 minus mu2 equal to 0. So delta value is 0. And sigma 1 square is variance of the first population. Sigma 2 square is variance of the second population. N1 is size of the first sample. N2 is size of the second sample. And here delta is difference between means of two populations, mu1 minus mu2. So if delta equal to 0 means delta equal to 0 is there is no significant difference between two population means. So that's why the difference is equal to 0. So delta equal to 0. If delta equal to 0, then this formula becomes x1 bar minus x2 bar by under root sigma 1 square by n1 plus sigma 2 square by n2. In one sample data, the standard error of sample mean x bar equal to sigma by root n. This we have discussed in one sample data. Here, two samples data. So that's why what is the standard error of two samples, x1 bar minus x2 bar is under root sigma 1 square by n1 plus sigma 2 square by N2. So here in this also we can calculate the mean of the population in which interval it lies. So confidence interval for population mean belongs to x1 bar minus x2 bar. This is mean of the first sample and x2 bar is mean of the second sample, and E is maximum error. Maximum error is defined as Z alpha by 2. This is tabular value, Z tabular value, into this is standard error of difference of means. So x1 bar minus x2 bar minus E, x1 bar minus x2 bar plus E. This is lower limit, this is upper limit. So in this interval, the population mean lies. Suppose the two population variances are equal, sigma 1 square equal to sigma 2 square equal to sigma square. These two population variances are equal, then the test statistic becomes Z is equal to x1 bar minus x2 bar by sigma 1 square equal to sigma square, sigma 2 square equal to sigma square. We can take it as sigma square as common. Under root means sigma. So take out sigma under root 1 by n1 plus 1 by n2. Suppose population variances are not given, then we take the test statistic as sample variances S1 square, S2 square. S1 square is first sample variance, S2 square is second sample variance. Here we are testing the hypothesis as there is no significant difference between two population means. That is, always we define the null hypothesis in difference of means is mu1 equal to mu2. There is no significant difference between two population means, or the two samples are drawn from the same population. Same population means mean is same. The same tabular values here also we apply to compare the calculated value and the tabular values. Now see the first example. The means of two large samples of sizes n1 equal to 1000, n2 equal to 2000. So clearly it is given that two samples. Two samples means we apply difference of means formula. So n1 mean of the first size of the first sample denoted by n1, size of the second sample denoted by n2. So n1 equal to 1000 and n2 equal to 2000. So two samples. Here we have taken two samples. Members are 67.5 inches and 68 inches. The means of these two samples are given. Mean of the first sample x1 bar. Mean of the second sample x2 bar. It is given as 67.5 inches and 68 inches. And also given that can the samples be regarded as drawn from the same population of standard deviation 2.5 inches. So the standard deviation of the population is 2.5 inches. Standard deviation of the population denoted by sigma, and two populations are equal, that is sigma 1 equal to sigma 2 equal to sigma, which is equal to 2.5 inches. So first population standard deviation and second population standard deviations are equal, that is given. Same population means only one standard deviation of that population, that is 2.5. So this is the data given. Now we test the hypothesis as null hypothesis we define, or we claim it as mu1 equal to mu2. There is no significant difference between two population means, or these two samples are drawn from the same population which has the standard deviation 2.5. So, alternative hypothesis. Alternative hypothesis is mu1 not equal to mu2 two-tailed test. There is significant difference between population means. Level of significance. So, in our estimation or in our claim, what may be the error? Level of significance is not given, that is, in general, we take alpha equal to 5% or 0.05. And test statistic is Z is equal to x1 bar minus x2 bar minus delta. Here we have claimed that mu1 equal to mu2. The difference of two population means is 0. That means means of the populations are equal. So what is the difference? 0. So delta is 0. So 67.5, that is mean of the sample, first sample, mean of the second sample. And this is sigma 1 square and sigma 2 square are equal. Sigma 1 equal to sigma 2 equal to 2.5. 2.5 whole square plus 2.5 whole square by size of the first sample is 1000, size of the second sample is 2000. Now the calculated value is minus 5.16. Always we compare the calculated value and tabular value by taking the modulus values. Even though we get negative, we take modulus of Z calculated with the tabular value. Z tabular value. So Z calculated is minus 5.16. So modulus of Z calculated is 5.16. What is the tabular value of Z for two-tailed? This is two-tailed test. At 5% level of significance is 1.96. So calculated value is greater than tabular value. So we reject null hypothesis H0 at a 5% level of significance. So what is the conclusion? We reject null hypothesis means we are accepting alternative hypothesis. What is alternative hypothesis? Mu1 not equal to mu2. That means the two samples are not drawn from the same population. Different population with different means. That is a conclusion about the null hypothesis. See the next example. Samples of students were drawn from the two universities and from weights in kgs, mean and standard deviation are calculated and shown below. Make a large sample test to test the significance of difference between the means. Difference between the means. Difference means definitely they will give two samples data. Samples of students were drawn from two universities. Two universities means two populations and two samples. So University A and University B. From University A or from first population, they have taken 400 students, that is the size of the first sample. That means a subset of this population. And subset of the second population or University B is 100. Size of this second sample taken from University B, and this sample contains 100 students. So N1 is equal to 400 and N2 equal to 100. These two are large samples greater than 30. And also given that mean of the samples is 55, and first sample mean is 55 and second sample mean is 57. And standard deviation of the first sample is 10. Standard deviation of the second sample is 15. So here two samples data is given. So from University A, one sample, from university B, another sample data is given. So this is first sample data and this is the second sample data. Sample mean is denoted by x1 bar, x2 bar. Standard deviation of the sample is denoted by S1 and S2. Size of the samples are denoted by N1 and N2. Now, this is the first step. Data we have written in the mathematical notation. Second step is hypothesis procedure. So, here we have defined or we claimed that null hypothesis is H0 is mu1 equal to mu2. That is, the average weight of both universities are equal. There is no significant difference between the weights of two universities, weights of the students from two universities. That is our null hypothesis. Alternative hypothesis as defined as a two-tailed test, that is mu1 not equal to mu2. Mu1 is the mean of the first population, mu2 is the mean of the second population. That means the mean weight of the first population university A and mean of the second population university B. These two university students mean weights are equal, that is a null hypothesis, and the contradiction of that statement is the alternative hypothesis. Now the level of significance denoted by alpha and which is equal to 5%, 0.05. And here we have claimed that mu1 equal to mu2 means delta value is 0. The difference is 0. So, x1 bar minus x2 bar. Mean of the first sample minus mean of the second sample. And standard deviation of the first sample, standard deviation of the second sample. Substitute all the values. We get Z calculated is minus 1.26. We take modulus value, that is 1.26. Always we compare Z calculated with modulus value. So modulus Z calculated is 1.26 and Z tabular value is for 1.96 two-tailed test. This is 1.96 for 5% level of significance in two-tailed test. Tabular value is 1.96 and this is 1.26. Now we accept null hypothesis since Z calculated is less than Z tabular value. Therefore, we accept null hypothesis at a 5% level of significance. There may be 5% error. So what is null hypothesis? What we have accepted? That is, the mean weights of two university students are equal. There is no significant difference between the weights of the two populations. Weights of the students from two populations. Next example, suppose that we want to investigate whether on the average man earn more than per week more than women in a certain industry. If a sample data shows that 60 men earn on the average x1 bar equal to 292.5 per week with a standard deviation of 15.6, while 60 women earn on the average 266.1 per week with a standard deviation of 18.2. So here we are claiming that two populations, men population and women population. We are claiming that their average income or wages per week are equal. There is no significant difference between men average income and women average income. These two are equal. There is no significant difference between men and women average income for per week. This is our null hypothesis. This is our claim. Here two samples are given. From men population, one sample is taken. From women population, another sample is taken. So here, first sample size, 60 men. 60 men are taken means first sample size is 60 and the second sample size is also 60. And first sample mean is 292.5. Second sample mean is 266.1. So, first sample mean is denoted by x1 bar. Second sample mean is denoted by 266 x2 bar is denoted by x2 bar. And also given that standard deviation of 15.6 and 18.2. So here we can take it as a S1 and S2. Sample standard deviations are given. So here this is the given data. So we can write this test statistic as S1 square and this is S2 square. So here H0 is mu1 minus mu2 equal to 20. That is the difference given here. There may be the difference between their average incomes is 20 rupees. That is mentioned here. And this difference may be greater than 20. That is alternative hypothesis. More than 20. More than 20 is alternative hypothesis. Always more than or less than or not equal. All these are alternative hypotheses. So we define the difference between the average income of men and women is more than 20 rupees means mu1 minus mu2 is greater than 20. And the difference is alternative hypothesis is 20 rupees. Difference is only 20 rupees. Alternative hypothesis, there may be greater than 20 rupees. That is alternative hypothesis. Level of significance we have taken here 1%, 0.01. And here x1 bar again substitute all the values, mean of the first sample, men average income, women average income and their differences, that is 20 rupees, and S1 square, variance of the first sample, variance of the second sample, size of the first sample and size of the second sample. After calculating, we get the Z calculated value is 2.068 and Z tabular value at 1% for one tail test. For one tail test at 1% is greater than 20 means right tailed 2.33. This is 2.33. So tabular value at 1% level of significance for right tail test is 2.33. Our calculated value is 2.068. So which is calculated value is less than tabular value. Therefore, we accept null hypothesis H0 at a 1% level of significance. So we are accepting means the difference is exactly 20 rupees. That is the average wages for men and women is exactly 20 rupees per week. This we are accepting. Thank you.